In today's lesson, we'll be learning how to factor and graph quadratic relations. If you recall, factoring turns a parabola in standard form into a parabola in factored form. Standard form is useful because the last value in standard form tells us the y-intercept, which is located right over here. Factored form is useful because it indirectly tells us what the x-intercepts are. It's a little bit more complicated than that, but essentially you can find it indirectly, and these are the x-intercepts. In our first example, we want to factor a parabola in standard form. First, let's identify the values of a, b, and c. The value of c is positive 4, and the value of b happens to be also positive 4. Let's begin by listing some factors of positive 4. Let's start with the obvious, 1 and 4. Well, 1 times 4 is 4, and 1 plus 4 is 5. As you can see, these numbers don't match up, so the factors of 1 and 4 are probably not the correct ones. Let's think of some other factors. Let's think of 2 and 2. Well, 2 times 2 is 4, and 2 plus 2 is 4. So that looks like a good match. Therefore, when I factor my parabola in standard form, it becomes x plus 2 multiplied by x plus 2. In the next part of example 1, we want to graph our parabola. So let's rewrite our parabola in factored form. We just figured that out in our previous question. To figure out the y-intercepts, all we need to do is substitute x is equal to 0. So instead of writing x, I'm going to write 0, and everything else stays the same. Now, 0 plus 2 is just 2, and 0 plus 2 is again just 2. And if you simplify that, that should be pretty simple. That is equal to 4. Therefore, my y-intercept is 4. Let's write it on our graph somewhere over here. In the next step, we want to find the x-intercepts. So let's begin by rewriting our parabola in factored form. We figured this out in part A. You need to sub y is equal to 0. So I'm going to change y into a 0, and everything else stays the same. Now at this point, you know that if you multiply this binomial by that binomial, your answer is equal to 0. So either the first binomial is equal to 0, or the second binomial is equal to 0. So you can just rearrange these. So I'm going to subtract 2 from both sides. So that's x plus 2, subtract 2 equals 0, subtract 2. That cancels out. So I have x is equal to negative 2. And if you didn't notice, the exact same thing happens over here. So I'm going to subtract 2 from both sides. That disappears. Then x is just equal to negative 2. So as you can see, we only have one x-intercept, and the x-intercept happens to be negative 2, which is right over here. At this point, you need to draw your parabola, and it has to be nice and smooth and symmetrical. Since it only has one x-intercept, it can't cross the x-axis more than once. So it probably is going to look something like that. And what we've done is we've first factored our quadratic relation, and then we have graphed the parabola using its y and x intercepts. In our second example, we want to factor a parabola in standard form. Let's first identify the values of a, b, and c. Well, the values of c are positive 6, and the values of b are positive 5. So let's first think of some factors of 6. So let's think of maybe 1 and 6. Well, 1 times 6 is 6, but 1 plus 6 is 7. So that doesn't work. Let's try other factors. Let's try 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. Therefore, that looks to be correct. So our factors are 2 and 3. Let's factor our parabola now. So that would be x plus 2 multiplied by x plus 3. So at this point, we want to graph our parabola, but we need to determine its y-intercept and or x-intercepts. So let's go ahead and figure that out. From the previous step, you know that the parabola in factored form is x plus 2 multiplied by x plus 3. To figure out the y-intercept, we need to sub x is equal to 0, so all I need to do is replace the x with a 0. Everything else stays the same. Now, you know anything plus 0 stays the same, so 0 plus 2 is 2, 0 plus 3 is 3, and all you need to do now is multiply these two numbers. 2 times 3 is 6. So I'm going to draw in my y-intercept, and it's going to be at positive 6. Next, I'm going to determine the x-intercepts. So let's go over here. Let's rewrite our parabola in factored form. So that's x plus 2 multiplied by x plus 3. When you want to find the x-intercept, you sub y equals 0. So you change that to a 0. Everything else stays the same. However, this means that when you multiply x plus 2 multiplied by x plus 3, you get an answer of 0. So either x plus 2 is equal to 0 or x plus 3 is equal to 0. So at this point, all you need to do is do the opposite operation. So I'm going to subtract 2 from both sides of the equation to get rid of it. That cancels out. X is equal to negative 2. Now over here, you have x plus 3. To get rid of the plus 3, you need to subtract 3 from both sides of the equation. That cancels out, so you get x is equal to 0 minus 3, which is just equal to minus 3. So we know our two x-intercepts. They are negative 2 and negative 3. Let's go ahead and draw them over here. So negative 2 is over here, and negative 3 is over here. So remember, we want to draw a nice, smooth, and symmetrical parabola. So I would think it would look something like this. And there you go. We've just factored and then graphed our parabola using its x and y intercepts. In our last example, we want to factor a parabola in standard form. Let's first identify the values of a, b, and c. So we know that c is equal to positive 3. And we know that b is equal to negative 4. Since we have a mix of positive and negative numbers, we know this is going to be a little bit of a trickier question. So let's begin by listing some factors of 3. Let's think about 1 and 3. Well, 1 times 3 is 3, but 1 plus 3 is positive 4. So that means that is not going to work, but we are very close. So maybe we should play around with some of these signs, okay? Let's try negative 1 and 3. Well, negative 1 times 3 is negative 3, and negative 1 plus 3 is positive 2. So as you can see, that does not work. Well, let's try the opposite. Let's make 3 negative. So 1 times negative 3 is negative 3, but 1 plus negative 3 is negative 2. So that doesn't work. But we are getting a little bit closer. Let's try making both of these negative. So negative 1 times negative 3 is positive 3, and negative 1 plus negative 3 is negative 4. So there we go. We've just figured out our factors. Therefore, our parabola in factored form would be equal to x minus 1 multiplied by x minus 3. At this point, we want to graph our parabola using its y-intercept and x-intercept. So I'm going to start by rewriting the parabola in factored form, which I just determined in the previous step. So it was y equals x minus 1 multiplied by x minus 3. So to find the y-intercept, I need to sub x is equal to 0. So instead of writing x, I'm going to write 0. And 0 subtract 1 is just negative 1, and 0 subtract 3 is just negative 3. So now we have multiplication. Negative 1 multiplied by negative 3 is positive 3. So let's go ahead and write in our y-intercept at positive 3. All right, so let's next find our y-intercepts. So I'm going to rewrite my parabola in factored form. So that is x minus 1 multiplied by x minus 3. To find the x-intercept, we need to sub y is equal to 0. So instead of writing y, I'm going to write 0, and everything else stays the same. So we know that this multiplied by that gives us 0. So either x minus 1 is equal to 0, or x minus 3 is equal to 0. So we need to isolate x. So the opposite of negative 1 is plus 1, and we're going to do that to both sides of the equation. That cancels out. X is now equal to 0 plus 1, which is just 1. We're going to do the same thing over here. The opposite of negative 3 is plus 3. And we're going to add 3 to both sides of the equation. That cancels out. So x is equal to 0 plus 3, which is the same thing as just 3. So we figured out our x-intercepts. They are 1 and 3. Let's go ahead and write them in. So 1 is over here and 3 is over there. Remember, we want to draw a nice, smooth, and symmetrical parabola. So I think it's going to look something like that. And there you go. We've just factored and graphed our parabola using its y and x intercepts.